Hi, I'm Ramya, Embedded Software Engineer at Microsoft Technologies. Welcome to this project demo where we will be showcasing a smart street light controller system using TDCI, which is Target Device Communication Interface. In this video, we will explore how streetlights can be automated using real-time sensor data. This project uses Arduino to control streetlights based on the ambient light conditions. Using TDCI, we connect the simulated environment to the real hardware, allowing us to control and monitor the system in real time. The goal is to improve energy efficiency by automating the streetlights, turning them on when it gets dark and off when it's bright again, all through a robust and flexible system. TDCA is a system that allows developers to connect a simulated environment, such as an RTOS simulator, with real hardware devices like Arduino Cortex boards like that. It facilitates two-way communication, enabling the host machine to send commands to the target hardware and receive feedback, allowing for real-time testing and debugging of applications. For a deeper understanding of TDCA and how it works, make sure to check out our other video where we explain TDCA in detail and show how it connects simulated environments to the real-world hardware. Okay, let's see this system automatic streetlight controller which automates the controlling of street lights based on the ambient light using our embedded system. Here we are using a Arduino board. TDCI allows developers to control and monitor street lights through a simulated ATAS environment on a host machine which communicates with the physical hardware like our LED sensors and the target device. Let's see this streetlight control logic. Um, Here, this street controller logic, such as turning lights on at dusk and off at dawn, like when it is automatically turning on the during evening time and turning off on the morning time. It is developed and simulated on the ARTA simulator running on a host machine like our PC with Windows or Linux operating system. Here, TDCA enables the host to simulate how the street lights will behave in real conditions, allowing developers to test and refine the control logic before deploying it on actual hardware. TDCA establishes a communication channel between host and target hardware via serial communication with USB serial interface. The host sends command to the target, like turn on the LED light based on the sensor, which the target hardware executes by controlling the actual LED by simulating the street lights. This ambient light sensor, such as here we are using a sensor LDR sensor. You can see here this is a light dependent sensor. This is connected to the target hardware, which is our Arduino Uno, which can detect real-time condition and send feedback to the host via TDCI, allowing the system to adjust the light settings dynamically. Using TDCI, the developer simulates real-world conditions like changes in the light levels. So the whole system sends command to adjust the street lights based on the sensor input. So based on this LDR, it works. For example, if a light sensor detects that it is getting dark, the target hardware receives a command from the host to turn on the street light. With TDCA, developers can also monitor the status of the street lights, example whether the light is on or off, like that, and dynamically adjust the control logic in real time for improving the system efficiency before actual deployment. The host can receive feedback from the target, such as the status updates of the LED light, like in real time, you are using a bulb. So, to helping to fine tune the control system. Here you can see the components. One is LDR and Arduino Uno, which is the microcontroller we are using here, and LED for instead of bulb, we can use LED for simulation purpose. So these are the components we are using here. And here, let's see the workflow of this. Number one, the simulated environment. The host simulates a street light control system in the RTOS environment where it schedules light to turn on or off based on the ambient light readings. And number two, the communication transmission. Through TDCI, the host sends a command to the target hardware, which is Arduino, to turn on or off the lights when certain thresholds are met. Like when it gets dark, the sensor value will be changed, right? So based on that certain threshold, the LED should work on that. And number three, real hardware execution. The target hardware controls the actual light, which is LEDs, simulating a real world street lighting system. And then number four, feedback to the host. That is the response. The target sends information back to the host, such as the light status or the sensor readings data, allowing the host to adjust the system or verify the commands were executed correctly. So this is how the TDCA makes a vital role on this project for this ARTAS simulation. Okay, let's see the real hardware, how it works. Okay, let's see the code. You should add this include file on tdca.h, which is necessary to use tdca calls. And from this application start function, from beginning you must call this tdca init. This is the API used for making a serial communication between host and target. So according to my PC, I gave the comport number 7. So based on your PC, you just give your comport number. Okay, now I just going to run this by right click open with system editor. Okay, now you can see the command and the response from target is giving Arduino Uno, and each command is sending by the host and response is coming from the target. So you can see that there is no darkness detected, LED is turned off. When I'm trying to detect my sensor, then you can see that darkness is detected and LED turned on. So this is how for each host command target is responding. For each command we are using a mutex concept. So this is for make sure that only one task can read or write to prevent data corruption or unexpected behavior. So this is how we use ATAS application with TDCA concept. Let's see the hardware setup. So here I am using a LDR sensor, LED and Arduino Uno target board. Here I made a required wiring connection for both sensor and LED. So now I am going to run this project. So initially this LDR sensor is detecting my ambient room environment, so that it is detecting there is no darkness in my room, so that the LED is turned off. When I'm trying to detect the sensor by just closing that, so it can detect the darkness. Now you can see my LED is glowing. So when again if I remove my finger, so that this LDR sensor detecting my surrounding ambient light. So as of now it is detecting there is no darkness, So that's why my LED is turned off again. So just make sure you connected the USB cable to the host PC, and make sure this TXRX is blinking. So this is the indication that your project is running on the target board. So this is how we are using TDCI. So developers can simulate and control a streetlight system in real time using this host-based simulation and interaction with actual hardware. This improves development efficiency and allows for dynamic testing, making it a powerful tool for creating smart city solutions like this automated street lighting. That's it. Thanks for tuning in. If you found this helpful, stay connected for more artist related videos. Bye.